For my lab, I filmed the Skyview Ferris wheel by Centennial Park and tracked the motion of the VIP gondola in Tracker. Therefore, the purpose of my lab was to model the Ferris wheel's change in position over time using Newton's second law and other physics principles. The main result of my lab was that the motion was a lot harder to predict than I had previously expected, probably due to error in filming or measurements of the Ferris wheel. I started off with net force, equal to net force of perpendicular plus net force of parallel. Net force is equal to dp dt. To find the change in momentum, we can use the momentum principle. To find F net perpendicular, we must first find delta theta, which equals r1 times r2, divided by the magnitudes of r1 and r2. Omega equals delta theta divided by delta t. Then, velocity is equal to omega times radius, and F net perpendicular is equal to mv squared over r. Using the position data found in Tracker, I created a CSV file and imported the file into Python. Then I looked up the data needed to apply the physics principles to the Ferris wheel motion. I found that the mass of each of the 42 Skyview gondolas is 4.32 kilograms. The radius of the Ferris wheel is 100 feet, or 30.48 meters. The initial and final positions were found in Tracker, and the total time was 1.402 seconds. In Python, I plugged in all of the information and used the same code from Lab 3 where the star orbited the black hole. I used the same way of looping through the CSV file as in the previous lab, and the same way of calculating dp/dt and therefore Fnet. However, to calculate Fnet perpendicular, I plugged in the formula mv squared over r and used Fnet minus Fnet perpendicular to find Fnet parallel. I also adjusted the individual arrow scales to point in the directions for Fnet, yellow arrow, Fnet perpendicular, blue arrow, and Fnet parallel, black arrow. The result was that the model correctly found Fnet, Fnet perpendicular, and Fnet parallel, but the model was not as accurate as I expected, possibly because of blurriness in filming or not exact measurements of the Ferris wheel. Thanks for watching.